Hello everyone, welcome to Matplotlib. So today we'll be continuing with the previous topic what we stopped with the counter plots. So if you remember that in the previous session we'll be moving towards to see that how the counter plot will be working on that. So the same thing we are continuing with the wireframe form and the surface plot. Whatever the values we are taking for this, we are continuing with that. So no need to just importing once again. But yes, if you do want like separately in this, you need to import it and you have to take it all the values once again, the XYZ, what the values we are taken. But already we are taken here the XYZ values, you can observe it there. We use the same value to use it the particular wireframes on the surface plot. So let's start on that. So we are going with the start with the fig. So fig equals to plt.figure figure, and we just here you can give the fig size as well if you want to give for the particular fig size. So if you want it, you can give inside this bracket the fig size. Let's move to continue with the ax.plt.axis. like we need to go with the axis of the projection of 3D. That will be the compulsory because we are working for the 3D projection equals to 3D. So this is done. Let's move to, already we are taking XYZ, yeah, capital. So I'm not taking once again, so we just want to use it that. So ax.plot and the plots wireframes. So for that we use the keyword wireframes, WIREFRE. First we'll see wireframe, then we are moving to wireframe and then surface plot. So first is wireframe plots. So wireframe, now we are moving to capital X comma capital Y comma capital Z, which is already we are taken in the previous frame. Let's move to color. So suppose I'm giving here the color is black. So color is your wish, what colors you want it, you can give that particular color. Let's move to set the title. So ax dot set title, TITLE. In a title, because we are working for the wireframe, so we are going with the wireframe as a title, WIREFREME. So this particular things are created properly. So here what happened, we just go with the normal plots and we just go with the projection and just create it. So we can run this. Wait a minute, it will be going to show you the wireframe on that. And then let's move to going to the things where we have to go with the next is surface. So going with ax equals to plt.axis, and then we are moving to projection. So projection equals to 3D, and when we done with the projection, we are going with the plotting. That ax dot plot surface, because we need to go for the surfacing now, plot surface, and then we are moving to go with the XYZ, X comma Y comma Z, XYZ. And now the restriction things what we give for those particular, here we just try to give the different values and different things. So we are just going with that RSTRID restride RSTRIDE equals to 1. So restride equals to 1. CStride also we need to give the 1. So this thing, it's like if you want to skip it, you can skip it. It's just for to look very in a proper way with the colors. So we just giving those thing. Then C map, I'm just giving the varieties for the another color, VRIDIS, and then we are moving to the VIRDI VRI and DIS, and then we are moving to the things of the edge color, that is EDGE edge color, COLOR edge color equals to none. So that is done with the colors things. Let's move to set the title. ax dot set title, ax dot set title, TITLE. in a title it's surface 1, so going with the surface. Yeah, so when you go with the surface XYZ and the RS3D construct word is CMap, so when you run this, you will get in that particular area in that way. Like the colors will be in that, what you gave it to that. So now what we'll do, we are just moving to the plotting 2-dimensional. It need to be rectilinear, like we need to do on these things to the rectilinear, and it like going with a partial polar grid for the surface 3D. Let's see how we are doing that particular things with this particular area. So let's continue with this. So for that we are just going with the R equals to np dot linspace, and then we are moving to the values 0, 6, 20, the values are there. After the values, we just move to theta. Theta equals to np dot linspace, just going with linspace, and then the values you have to going with the value 0.9, going with the np dot pi comma 0.8 star np dot pi comma 40. So this is for the theta values, like we need to change it, right? So for that we use this particular area. Let's move to the other line, r comma thetas, both the things what we taken here are comma theta, and then we are going with the equals to np dot mesh grid and just going with r comma theta. So r comma theta is done, and now the xyz values, like, so we are going with x equals to r into np dot sin theta theta, as well as for the y equals to r into np dot cos, because one is sin and one is cos theta. Theta done, and then we are moving to z equals to f of x and y, x comma y. Yeah, now let's move to plot it. So ax equals to plt dot xs, and then just moving to projection, going with the PROJECTION, projection equals to 3D, and the last one for the plotting of surface, ax dot plot surface SURFACE surface, and just moving to the all the values x comma y comma z comma. Now the what is the same thing we are giving here as well, what we give for this particular area. So I'm just taking from here only, I'm just copying this particular, so we just go with this, and here we can give those particular restriction of these things are there. So now we can run this, wait for a while, you can observe it comes to that particular way. So this is how you have to use the 3D looks in your using the matplotlib. You can observe we just go with this and we got this particular 3D view. So with this you can design all these pictorial formats, all this pictorial things in that what you wanted to going with all this particular area. So I hope you're clear with this thing. So in the next session we'll see the last one, that is your surface triangulations using the Matplotlib 3D. Thank you.